In this DeBacco University video, I'm going to be describing what percent composition is and walk you through some steps on how to calculate it. As the name implies, percent composition, we're taking a molecular structure and we're determining what percentage of that molecular structure is oxygen, carbon, and hydrogen for sucrose, as this example shows, but we could do this really for any molecule. So first off, percent composition in its most broad terms tells you the percentage by mass of each element in that compound. This information is critical for understanding the chemical identity of substances and is often used in determining empirical as well as molecular formulas. So again, molecular formula, percent composition, how much of those individual elements comprise that total compound. So how do we go about this? Well, step one is we want to find the molar mass of the compound. We want to add up the atomic masses of all atoms in the chemical formula. As a reminder, molar mass is the sum of masses of all the elements in the formula. The mass of 1 mole of a compound, essentially 1 mole, is the same as 6.02 times 10 to the 23rd molecules there. Where do we get that molar mass? We're typically reading that from the periodic table. After we get our molar mass, then we're going to calculate the mass for each element. So multiply the atomic mass of each element by the number of atoms of that element in the formula. So we take the molar mass for Fe2SO4 to the third. For iron, Fe is 55.85. Again, we get that from the periodic table. There are 2 of them, so we multiply that by 2. For sulfur, we get the molar mass, we multiply that by 3. The reason why it's 3 is these are in parentheses, this polyatomic ion, so that 3 gets distributed. In oxygen, there's not 4 of them, there's actually 12, because we have got 3 of these molecules, each with 4 oxygens. That's how we get to 12. We take all of these, we add them together, and we get our grams per mole here. You can also see that here for another molecule, following the same process as we go through to multiply by the quantity, getting the average atomic mass from the periodic table, getting the subtotal, and adding them together to get that molecular mass. Once we've got the molecular mass, well, now we can use the percent composition formula. So what does that look like? So the percent composition equals the mass of the element divided by the molar mass of the compound times 100. So what does that look like? Well, here we're looking at Na2CO3. We went through this previous step on the previous slide, showing you how we got the masses from the periodic table. We multiplied by the number, we added them together, and we get our molar mass. Now we're going to go to the next step to get the percent composition. So now we're taking the mass of the individual elements here. So for example, the first one, Na or sodium, would be 46 grams. We're dividing that by the total here, 106. For carbon would be 12, and for oxygen would be 48. Divide by those times by 100, and now we're getting our percentages. So this would be 43.4% sodium, 11.3% carbon, and 45.3% oxygen. Here's some other examples here, walking you through the steps again. Find the percent composition for Cu2S. We can find the molar masses from the periodic table, multiply by the number of atoms we have in that compound, get our total here. We take each individual atom here, or element for copper. We take the mass there, divide it by the total. Same thing we do for sulfur. Take the total grams, divide it by the total grams of the compound, multiply by 100, and therefore we're calculating our percent composition of this, of copper and sulfur by mass. Now the basic steps are consistent, so you sum all the percentage compositions, should be close to 100%. There might be a slight difference due to rounding, but that's a great way to be able to check your work as always. Use the atomic masses from the periodic table with at least 2 decimal places for accuracy, and this method works for any compound. Just follow the same formula, do it a couple times, and hopefully it won't seem as daunting as it did at the start of this video.